Class 114 N-channel enhancement type MOSFET. Of different types of MOSFETs, you have to study only one. So this is N-channel enhancement type MOSFETs. On a P material, two heavily doped, P means moderately doped, N plus means heavily doped. Two N plus materials are diffused, means placed. Now, since there is no contact between these two N plus regions, there is no chance for the current to flow. Now, above these two regions, a metal oxide is this one is metal oxide, SiO2 is kept here. That is an insulator, and these are the contacts, metal contacts for source, drain and gate. The three terminals are called as source, gate and drain. Body is another one. Usually body is connected to the source. We will see the operation now. Source, gate, drain. When drain is made positive with respect to source for N-channel E-type MOSFET. When drain is made positive with respect to source, this is forward biased. But there is no chance for the current to flow because there is no contact between source and drain. This is the load resistance, say. So no current can flow because there is no contact here if gate is not present. Suppose now you give gate a positive voltage with respect to source. Source is common. Now what will happen is this positive will attract electrons from the P body, okay, and repel holes. Holes will come down. In this P material, there will be some holes and free electrons. So the holes will be pushed down because gate is made positive. So electrons are attracted towards the gate. But due to the presence of silicon dioxide, electrons cannot come into the contact of gate. They are just available at the gate terminal, near to the gate terminal. So when electrons are accumulated near the gate terminal, that is near the metal oxide layer, a N channel means electron channel is formed between the source and drain. So it will now conduct and current can flow like this. In a transistor, when there is base current, collector current can flow. In MOSFET, when there is gate voltage, collector current or the drain current can flow. The symbol of an N-channel MOSFET is like this. See, this is the gate and drain and source are kept opposite, okay, drain, gate, source. In between we have body, that is p-type substrate. Gate is kept at the other side. Usually source and body substrate are connected together. If that is the case, in the symbol you can see here source and body, that is substrate, are shorted. This silicon dioxide layer is also called as MOS capacitor, gate terminal and P terminal. In between we have dielectric. Similar to BJT, you have three types of operation: cutoff, saturation and ohmic region. If this is made high enough, then this will be fully on. If this is lesser than the threshold value, minimum value, there will be no channel, fully off. If it is within those two values, this will act as linear, in the linear region, active region. This induced channel, due to the application of gate, it is called as induced channel because it is induced when the gate is applied. This channel is also called as inversion layer because in a p-type substrate, n-type channel is formed. Since the channel is n-type, we call it as n-channel MOSFET. Enhancement type means when we give gate voltage, then the channel is formed. Now, one advantage of MOSFET is the gate power loss is less. In case of transistor BJT, the continuous current flow is necessary. Here, due to the dielectric, current is not flowing in the gate circuit. The voltage current is necessary only during when you are applying the gate. Once the conduction takes place, then the gate voltage is enough, because channel, once it is formed, then there is no need of current flow. Just for accumulation of charging, then for that purpose only you need gate current, otherwise gate current will not flow. Hence this has lesser loss when compared to the transistor BJT. If it is n channel, arrow mark is inside, we have to remember like that. This is gate, drain, source. Write gate to one side and then write drain, source and in between substrate. Drain, source, in between substrate. And in case if they are shorted, show short. There is a term called conductivity modulation, means as the gate voltage increases, conductivity also increases. So variation of conductivity with respect to gate to source voltage is called as conductivity modulation. You can see here the current, drain to source current will be 0. There will be no gate current, no drain current till gate voltage is with minimum value, threshold value. After that, this is linear region, then it is saturation. So after that, any increment in the gate voltage will not have any effect on current. Current would become saturated. So this is a cutoff region, this is saturation, this is the linear region. When slope is, there is something. Here you can see slope is almost infinity. If we are operating it as switch, then we will operate here in this region and in this region. This is transfer characteristics, means output with respect to input, that is called as transfer characteristics. Output is drain to source current, input is gate to source voltage. Next, this is output characteristics, means output current with respect to output voltage, means the biased voltage. This is not asked in your syllabus. So this is similar to the BJT characteristics. You draw here collector 2 emitter voltage, and here you draw collector current, and here you show it for different base currents. Here we show it as for different gate voltages. That's all. This is the cutoff region, this is saturation region, and this is the linear region. Now we will move to power MOSFET. In case of power MOSFET, an extra layer, N minus layer is added. Rest everything is same. See here, an extra layer, drift, that is called as drift region. It increases the blocking voltage because it is lightly doped. Rest everything is same.